In this class, we'll discuss about ROC, region of convergence for Z transform. Then finally, we'll solve the problem based on the region of convergence. Suppose if the discrete time system is causal, that only causal, we are not worried about other characteristics. Okay, that means what the system may be stable or may not be stable. We are not worried about the stability, but we are worried about only causal because the causal system may be stable or may not be stable. That's why I'm writing only causal. Okay, if the system is causal, okay, then mod z has to be always greater than some number a. Again, the value of a could be anything. It may be less than 1 or greater than 1. Whenever we are using modulus, we know that it is just a number, positive number. It's like a radius of the circle. Okay, because in the z transform or OC concept, we will always deal with the circle. Okay, the circle will have radius. Again, the radius can never be negative. So if mod z is greater than a, definitely the system is causal. Again, a could be greater than 1 or it may be less than 1. Okay, that then our reference circle is z equal to 1. Mod z is equal to 1. So for example, if a is greater than 1, say for example, a is equal to 2, then we have to draw another circle with the radius of 2. Then ROC is greater than 2. Okay, that means outside the circle with the radius 2, we are having the ROC. This is the region of convergence. Or otherwise, a also may be less than 1 also possible. Say for example, if a is 0.5, okay, then also what we need mod z is greater than a, that is 0.5. Okay, so this dotted circle, okay, this circle is the reference circle, that is mod z is equal to 1. Okay, this is actually mod z equal to 1, but we are inside that 1. So that's why again the radius is less. That means what, mod z is equal to 0.5. Again, outside the 0.5 circle, we are drawing our region of convergence. Okay, and one thing we have to consider here, in this case, we are including the unit circle. That means mod z equal to 1, but in this case, we are not including. Okay, that will affect the stability of the system actually. But at this point, we are not worried about the stability of the system. We are only worried about causality nature of the system. That means what, finally, the ROC must go outside the circle. Okay, outside of some circle, the circle radius may be less than 1 or maybe greater than 1. Okay, then suppose if the system is non-causal, it is just opposite. That means mod z is less than some number, less than a. Okay, say for example, mod z is equal to 1. This one is the reference circle. Okay, now again, suppose if a value is 2, that means this is the bigger circle with the radius 2. Then ROC is going inside the circle. ROC is inside the circle. Okay, that means mod z here now ROC's mod is less than 2. So this is the region of convergence. Okay, so this is the region of convergence. Okay, but if you see here again, this one is the mod z is equal to 1 is the reference circle. Suppose in this case a value is 0.7, then definitely 0.7 will lie inside the unit circle. Again, ROC has to go inside the circle, not outside the circle, because this is non-causal nature. So mod z less than 0.7 is the ROC here. So again, finally, if the system is non-causal, definitely ROC will be inside some circle. Okay, that circle radius may be greater than 1, that is 2, or maybe less than 1, that is 0.7. Again, here also we are not worried about the stability nature, but if you see here, in this case, we are including the mod z equal to 1 circle, but here we are not including. So that will affect the, actually that will affect the stability of the system. So next, stability nature. Again, when we deal about the stability here, we are not worried about the causality nature of the system. Okay, that means what, the system is stable, but may be causal or may not be causal. Okay, but so we are worried about only the stability nature. Okay, so if the system has to be stable, okay, then what is the concept? It must include unit circle, the ROC. Okay, the region of convergence. It's very important statement. If the system is stable, okay, the region of convergence must include unit circle. The similar concept we have studied in Laplace transform also. Okay, if the system has to be stable, okay, the ROC must include j omega axis. Okay, because we know that j omega axis is something similar to unit circle mapping. Okay, unit circle. J omega axis is something similar to unit circle. Okay, so again, this one is the reference circle. Okay, this one is the reference circle, that is mod z equal to 1. Okay, mod z equal to 1. Suppose if mod z is greater than 0.5 is defined, definitely 0.5 is the smaller circle. Okay, this is the 0.5 circle. Okay, but ROC is outside the 0.5 circle, that means going outside. So in this process we are including the j omega, we are including the unit circle. Okay, so the mod z greater than 0.5 definitely includes the unit circle, so definitely this is stable system. Yeah, and also if you see here, um, again this is the reference circle, unit circle, but now my mod z is less than 5. Okay, definitely 5 will be the bigger circle, but ROC is inside the 5. Okay, that means the line will come inside. Definitely in this case also we are including the unit circle, that's why the system is stable. Okay, so suppose for example, if it has like this, say for example if mod z is less than 0.5, definitely this is not a stable system because we are not including the unit circle. Suppose here if mod z is greater than 5, definitely we cannot include the unit circle. Again, this is also a unstable system. Okay, so stability means definitely we have to include the we have to include the unit circle. Okay, stability means always we have to include the unit circle. Suppose if the system is causal as well as stable, okay, that is also possible. Okay, the system is causal and also it is stable. Yeah, again, separately we have seen the condition. Now we have to combine both the condition. That means what? If for the causality nature, definitely the ROC must go outside of some circle. Okay, and also we know that this is the reference circle. Okay, sorry, and we know that this circle is the reference circle with mod z is equal to 1. Okay, reference circle, mod z equal to 1. Okay, now what is the condition? Definitely ROC must go outside the circle for causality nature. But if I choose a pole outside the unit circle, again I have to go outside of that circle. Definitely I cannot include the mod z is equal to 1 circle. Okay, so that's why I have to choose a pole inside the circle, then I have to go outside. Okay, choose a pole inside the unit circle, then you go outside. Okay, so in this process you will be achieving, because as you are going outside you will be achieving causality nature. As you are inside the circle, definitely when you go outside, okay, from inside of the unit circle, definitely you can include the mod z equal to 1 circle. So that's why all poles must lie inside the unit circle. So for example, if it is only one pole, say for example mod z is equal to 0.2, then this is mod z equal to 0.2, then when mod z is greater than 0.2, okay, definitely you are going outside. Okay, mod z is greater than something, definitely it is causal. Again, in this process you are including the unit circle, so you are getting causal as well as stability nature. But why I am taking like all poles? Okay, for example, if there are more than one poles, okay, we know that say for example you take this condition. See, this is mod z equal to 1 reference circle, reference, that is unit circle. Suppose one pole is here, my another pole is here. Say this pole value is, say for example 0.5, another pole value is, say for example 4. Now uh, I cannot see, we may think that suppose if I choose mod z greater than 0.5, then we may think that we can choose ROC like that. Okay, we may think like that, ROC. But what is the main problem here? Okay, so in this process, we may get stability as well as causality, because you are going outside and also you are including the unit circle. But this is wrong procedure, because we are violating the condition of ROC. It is the condition ROC must not include, again, must not include poles. ROC must not include poles. Okay, see, in this process, your ROC consists of the poles. Okay, it is violating the condition, because ROC should not include the poles. Okay, in the region of convergence, there should not be any ROC. So then, what is the only way to choose? Either you have to go outside the 4 circle or you have to go inside the 0.5 circle. So what is the condition you can take here? Okay, so suppose if this is the situation, mod z equal to 1. one pole is inside, that is at 0.5, okay, and another pole is at 4, okay, mod z equal to 4. What is the only way you are having? Either you can go outside this circle, outside the bigger circle, or what is the other way you can do? You can go inside the unit circle. These are all the only possible ways, okay. You cannot go in between, okay. If you go in between, you are violating the condition. That's why for causal and stability nature, this is the main condition: all poles must lie inside the unit circle. Okay, if you think it in some other than this condition, if you take other, if you take any other possibilities other than these, okay, instead of choosing all poles inside the unit circle, definitely you may not be attaining this condition, causality and stability nature at a time. Okay, so now we'll try to solve the problems based on this. A linear time system is defined by h of z, and also we have to specify the ROC, okay, and determine h of n, because for this condition we have to specify ROC. We know that depending on the ROC, the result will vary. Okay, they are giving stability nature. Then what should be the ROC? What is h of n? For causality, what should be the ROC? And then what is h of n? For non-causal, what is ROC and h of z? We have to decide now. Okay. Solution just again, in this case, h of z is given directly, or it may be also be given indirectly with the help of difference equation, just to find out what is h of z. Now, in this case, it is given directly. So h of z is equal to 3 minus 4 z inverse 1 minus 3.5 z inverse 1.5 z power minus 2 is equal to 3z square minus 4z divided by z square minus 3.5z plus 1.5. Again, you can take z from both the term. That is 3z minus 4 divided by z square minus 3.5z plus 1.5. This is h of z. Again, we know that when we are operating with the positive power, we have to take the z downside. H of z divided by z, 3z minus 4 divided by z square minus 3.5z plus 1.5. Again, for that we have to find out partial fraction a by, again, what is the factor of this one before taking the partial fraction? What is the factor? 3z minus 4 divided by z minus 0.5 into z minus 3. You now apply the partial fraction. So h of z divided by z equal to finally 3z minus 4 divided by z minus 0.5 z minus 3. Okay, so a by z minus 0.5 plus b by z minus 3. What is the value of a? That is 1 by z minus 0.5 plus b, value of b is 2. 2 divided by z minus 3 is equal to h of z divided by z. Now, what is h of z? Just take z upward, that is z by z minus 0.5, 2z by z minus 3. Now we are having h of z. Okay, just write the h of z here. Z by z minus 0.5, 2z divided by z minus 3. Okay, so now clearly we are having two poles. Okay, one at mod z is equal to 0.5, another one at mod z equal to 3, mod z equal to 3. First of all, what is the condition given? Okay, we have to find out h of n for a ROC specified with stability, stability. Again, before just finding the stability, it's better to find out causality, or otherwise we can also find the stability, no problem. Just as we know the condition, stability means it must include only stability. Okay, we are worried about only stability. Okay, so it must, that means what? It must include the unit circle. It must include the unit circle. Now, say for example, this is the reference circle, that is unit circle. One pole is here, okay, at 3. That 3 means what? Entire circle. Okay, entire circle. Another pole is here inside at 0.5. Okay. Now I can draw a circle with 0.5. Okay, with 0.5 I can draw a circle with 0.5, and also another circle with 3, another circle with 3. Now we are having 2 circle. Okay, so uh, there are 3 different regions are possible. Like I can take the common ROC is finally mod is at less than 5. I can take mod is at less than 5, and also mod is at less than 3. That means mod is at is finally less than 0.5, or otherwise. Okay, what I'm telling in general, there are 3 different ROC is possible. Either in general, now we are not worried about stability. In general, I am telling we can take either mod z greater than 3, common ROC. Okay, mod z is greater than 3, or mod z is less than 0.5, or mod z is in between 0.5 and 3. Okay, so 3 different variety is possible. So now if I choose the first one, I cannot include the unit circle. That means I will be going outside 3, so I cannot include unit circle. That's why I cannot get stability nature. Suppose if I go inside the 0.5 circle, that means, and once again, I am not including the reference circle, that is unit circle. Again, in this case also, we cannot get the stability, because for the stability, definitely we have to include the unit circle. But in this case, there is the in this case, definitely we will include the unit circle, because we are choosing this region. That means mod z is greater than 0.5 but less than 3. That means we are choosing this region. Okay, we are choosing this region. Okay, in this region only we are getting the stability nature. Again, the system may be causal or may not be causal. We do not know that nature now. And again, we know that whenever the ROC is between the circle, definitely non-causality will be there, because one will go outside, another will go inside. Okay, so that means one signal will be going right side, another signal will be going towards left side. Okay, so now so h of z. Okay, now we have clearly defined for a stability, definitely the ROC is in between the circle, that is 0.5 to 3. Okay, so what is h of z now? H of z is equal to z by z minus 0.5 plus 2z divided by z minus 3. Okay, so with respect to 0.5, where is the ROC? With respect to 0.5, ROC is outside. Okay, with respect to 0.5, ROC is outside. Okay, because 0.5 is there, ROC is outside the 0.5. That means this is right-sided signal. The first signal is right-sided signal. So 0.5 power n u of n, 0.5 whole power n u of n. Again, with respect to 3, okay, with respect to 3, with respect to the bigger circle, where is the ROC? ROC is inside. ROC is inside. That means left-sided. Okay, so the second term is left-sided signal. We know that whenever the signal is left-sided, we'll be getting minus here. Already 2 is there. Okay, then 3 power n u of minus n minus 1. We know the standard formula. Whenever the signal is left-sided signal, we'll have one extra minus here. Okay, so this is h of n. Okay, this is h of n. Again, in this process, if you see, this may, the first term may be causal, second term is anti-causal. Finally, this is a non-causal system. Okay, this is a non-causal system. Okay. What is the second question? The second one is system is causal. Okay, what is the condition if the system is causal? Okay, just we'll find it on the next page. Okay, so the second one is again causal. Okay, what is h of z? h of z is equal to z minus z by z minus 0.5, 2z divided by z minus 3. Okay. Reference circle mod z is equal to 1. Okay. 0.5. Okay, this is the 0.5 circle. 0.5. And another circle with mod z is equal to 3. Okay. The green color one with mod z equal to 3. Mod z equal to 3. Now what we need the causality nature. Okay, we need causality nature. Okay, for that, suppose say for example, if we choose mod z greater than 0.5, we may be getting ROC outside, okay, completely. But you are including the one pole here, because one pole is there here at mod z equal to 3. ROC should not include poles. So definitely we cannot get these. Okay. And also if you choose in between mod is at greater than 0.5, less than 3, just now we have seen in this condition, we'll be getting again non-causal. Okay, but we need causal. So the only way is we have to choose mod is at greater than the largest pole available in the system. What is that largest pole? That is 3. So definitely mod z should be greater than 3. Okay, I cannot choose mod z greater than 0.5, because in that process I will be including the poles. Okay, the ROC must not include any poles. So mod z greater than 3 is the ROC. So the ROC, this is the region of convergence, ROC. Okay, so with respect to 0.5, definitely ROC is going outside. Again, this is the right-sided signal, so that I can write the right-sided signal. That is standard expression is 0.5 whole power n u of n. Again, with respect to 3 also the ROC is going outside. Here also again right-sided signal 2 into 3 power n u of n. Okay, if you see both are right-sided signal, again even from h of n also you can verify that. Okay, both are right-sided, so that's why this is a causal system. Okay, what about the last one? The last one is if the system is non-causal. Non-causal. Before that, let's write the h of z. Okay, h of z is equal to z by z minus 0.5 plus 2z divided by z minus 3. Okay, a reference circle with mod z is equal to 1. One pole at 0.5, another pole at 3. Okay, again that also will draw the circle. Again, okay, with mod z equal to 3. Okay, now what are all the possible ways? Okay, either definitely I may choose mod is at less than 3, or otherwise I may choose mod is at less than 0.5. Okay, or otherwise I may choose mod is at less than mod is at greater than 0.5 and less than 3. Okay, anyway, so because whenever it is non-causal, definitely the ROC is inside the circle. Okay, so we are choosing this condition. But mod is at less than 3 is not possible, because in this process we'll be including the 0.5 circle. So this is neglected. This is not possible. Mod is at less than 0.5 possible. Okay, mod is at less than 0.5. means we'll be choosing a region like this. Again, this is another critical condition. Okay, whenever we choose mod z greater than 0.5 and less than 3, in this process, we are getting one with right hand side, another one with left hand side signal. So whenever the signal is going both on right side and left side, generally we used to call it as a non-causal, non-causal. Or otherwise, if the signal is going only on left hand side, okay, we used to call it as a anti-causal. Okay, anti-causal. So again, this non-causal and anti-causal is maybe interchangeably used sometime. Okay, so we may assume this is the anti-causal also. Uh, so that means what if it is anti-causal? Really, both the signals are going towards left-hand side. Okay, if there are two signals, definitely again another signal also will go on left-hand side. Okay, so again interchangeably there may be confusion here, but if you assume that if they are asking like non-causal, that is anti-causal, that means what both the signals are left-sided, then we can write the result like the ROC is the correct ROC is mod is at less than 0.5. That means both the signals are going towards left. That means what with respect to these poles, ROC is inside. So left-sided signal, that means minus zero point 0.5 whole power n u of minus n minus 1. Okay, u of minus n minus 1. Again, with respect to mod z equal to 3, again the ROC is inside, again minus 2 3 power n u of minus n minus 1. So this is the answer. Okay, thank you.